Hey, so I thought I'd try this video opening with a joke about the periodic table of elements, but I just realized I wasn't in my element, so I thought I'd skip it. Isotopes! That was a joke, in case you missed it. I'll explain later. Isotopes! This is what happens when the number of neutrons is different. This was kind of an unexpected thing, but we finally switched. Oops, I'm in the way. Helium's the easiest one to see, then we'll look at some other examples. But helium comes in three forms. The H11, this means the top number is its atomic mass units, and the bottom number is its number of protons. Right? These are all hydrogens because they have one proton, so 1, 1, 1. But then we also see, sorry, let me get a pen. Right, so hydrogen here because it's, oops, I just erased the 1. 1, 1, and 1. So these are all hydrogen because they have one proton. However, what's really kind of neat about it is that they have different number of neutrons, right? So here we have 0 neutrons, so we have 1 atomic mass unit right here. But here in deuterium, still 1 proton, so it's still technically hydrogen, but we have a neutron here. Notice we still have just 1 electron, so there's equal charge, but we have 2 mass units. And then in tritium has 2 neutrons, so it's atomic mass of 3. But still 1 proton, 1 electron, and still hydrogen. These have slightly different atomic masses, so they do behave differently. Some of these isotopes can be radioactive, and we'll come back to that idea both in chemistry and in biology when we talk about radioactive dating of fossils. All right, so this is what an isotope is. It is the same element, but with different types or different numbers of neutrons. All right, let me erase my marks. So another example is carbon. Most carbon in the universe is carbon-12. That means it has 6 protons and it has 6 neutrons. Most carbon atoms in the universe are C12, just by how they form. It's a very stable atom. However, some other carbon isotopes exist where they have 6 protons and 7 neutrons, carbon-13 here, or carbon-14, which has 6 protons and 8 neutrons. And carbon-14 is actually radioactive, which is really important for how we know how old, for example, some fossils are. Again, we'll come back to that at another date. Point being here is some isotopes, they do have different mass than the main element does, than the one we typically find. So carbon-12, 6 protons, because it is the 6th element in the periodic table of elements, and most carbons will have 6 neutrons. When we get deep into the periodic table, we find a lot of different isotopes. Some metallic elements, for example, have many, many different isotopes. We'll worry about those when we come across them. Another way that things can change, again, excuse me while I erase my markings, is what are called ions. In this case, and then my picture's in your way again. There's no safe place for me to stand. Sit, show up, whatever it is. Ions have an unequal number of protons and electrons, so it ends up with an electric charge. So negative ion has, for example, 2 protons and 3 electrons. Given that this 2 protons make it helium, this is a very unlikely ion. Helium doesn't generally ionize, but it's, for illustrative purposes, it's good, right? Negative ion has more electrons than protons because there's 3 electric charges, 3 negative charges, right? So we have 3 negative charges and 2 positive, and so we end up with just -1. All right, so that's when you talk about ions. There's an unequal number of protons and electrons. Let me erase these before I switch to the next screen. Again, this is all in your readings, so please check there. And if you have other questions, please talk to me. So those are ions. So here's our summary of summaries of this whole section. It covers a lot of ground. We will be covering some of it in class as well. So we have this electrons orbit the nucleus. Remember, we don't really know where they are, so as we talk about the electron cloud, not really orbits in the sense of how a planet orbits, but orbits in the sense of it's somewhere in this vicinity. And we'll talk about that in a later lesson as well. Protons and neutrons are in the nucleus, so 99.999% mass of an atom is in its nucleus, so we can ignore the mass of an electron. So that means protons and neutrons make up most of the mass. So the atomic mass measures how much stuff is in the atom. So this is both the protons and the neutrons, because they're both about the same size, give or take. For our purposes, they're the same. And the atomic number is just the number of protons, and this determines which element it is. All right, and the number of protons, again, just tells you, we can go up here. Is it kind of weird that I just kind of maneuver the screen? It entertains me. Hope it entertains you. I hope these little slides are entertaining. If not, I'm just a dork, and you know what? Life is good. Anyways, protons determine your number of elements. Neutrons determine your isotope. And electrons tell you which ion it has. I will put this whole thing up on the screen for just a moment. This would be a good time to pause the video if you're taking notes. And why wouldn't you be? I'm giving you the highlights of each of the lessons. So please pause if you need to. Write these down. Time to pause. Are you done yet? Good. Okay. So these are summaries of this whole lesson 2. As always, if you have questions, please shoot me a message or come talk to me on the floor or in class if we have time. Because we've covered a lot of territory, and if you're careful reading in your textbook, you'll be doing great. And these videos just be a little help to get you moving. Again, see you guys in class or in the next video.